Okay, the question says the perimeter of a rectangle is 14 meters and the area of the rectangle is 12 square meters. What is the length of the longest side of the rectangle if both the length and the width are integers? So we have been given a rectangle, and let's assume its length is L and its width is W. Now for students in middle school or high school, you would be solving this with a quadratic equation. And you have two clues in here. The perimeter, which is twice length plus width, is equal to 14, from which you get L plus W is equal to 7. And then the area, which is L into W, is equal to 12. So from 1, I can say W is equal to 7 minus L, and replacing that in 2, I'll get the quadratic equation L into W, which is 7 minus L, is equal to 12, or 7L minus L square is equal to 12, or if I simplify this, L square minus 7L is equal to minus 12 is equal to 0, or L minus 3L minus 4L minus 12 is equal to 0, from which I get the factors L minus 3 minus L minus 4 is equal to 0, which gives the values of length could be equal to 3 or 4. Now we have to choose the larger of the two values as the question is asking. Then I'll choose L to be 4. And in case L is 4, then from 2, W is area, which is 12 by L, equal to 12 by 4, or width is equal to 3. Right, so the dimensions of the fields are length is 4 and width is 3. Now this is all good if you are familiar with quadratic equations and you know how to solve them. This is a very simple quadratic equation. But what if you have to explain this to a third grader or a fourth grader? In fact, I have seen this question in one of the math Olympiad or possibly Perennial math for the third grader or the fourth grader, I think. So there's another way to solve this problem without using the quadratic equation, and that is through tables and charts. We would be using the same formulas but in a different way. So let's look at the clues given to us. First clue given to us is perimeter is equal to 14. Now we know perimeter is twice length plus twice width is equal to 14, or taking 2 as common, length plus width is equal to 14, or length plus width is equal to 14 divided by 2, or length plus width is equal to 7. And again, it's said that the area, which is equal to length into width, is equal to 12. Now, for a third or a fourth grader students who have just learned how to write factors, we have to use factors to find out what combination will work. So in this case, we will work off this number 12. and we'll create a chart or a table after we find out what the factors are. So we know the factors of 12. One, 2, 3, 4, 6, and 12. Now what we do is, to find the best combination of length and width, we have to use these factors. We have to find out which combination of the factors work, and that's where the charts come in. So let's create a chart. With the lengths 1, 2, 3, 4, 6, and 12. Now, if these are the lengths, one of these would be the length that we are looking for. Let's find out what the width would be in any of these cases. Now, if we go with 1, each time we would divide 12, which is the area, with the width, with the length here, to find out what the width would be. So this would be 12 by 1, which is equal to 12. In this particular case, it will be 12 by 2, or 6. In this case, when the length is 3, the width will be 12 by 3, which is 4. In this case, when the length is 4, the width would be 12 by 4, which is equal to 3. In this case, length is 6, so the width would be 12 by 6, which is equal to 2. And in this case, when length is 12, the width would be area divided by the length, which is equal to 1. So, if the lengths were 1, the width of that field would be 12. If the length was 2, the width would be 6. If the length was 3, the width would be 4. If the length was 4, the width would be 3. If the length was 6, the width would be 2. If the length is 12, the width would be 1. In that combination, each of these fields would produce an area of 12. However, we also have to see what the perimeter is. Now, in this particular case, when the length is 1 and the width is 12, perimeter is 2 times length plus 2 times width, which is 2 plus 24, which is 26, much more than what we have been told. We know that the perimeter is 14, right? Perimeter is 14. In the second case, when the length is 2, the perimeter would be twice the length and twice the width. So 12 plus 4 is 16. In the next case, when the length is 3 and the width is 4, the perimeter would be twice length plus twice width, which is 14. In this case, in the next case, when the length is 4 and the width is 3, the area would be 8 plus 6, 14. When the length is 6 and the width is 2, the area would be 12, twice the length, and twice the width, 16. And in the last case, when the length is 12 and the width is 1, it will be twice the length plus twice the width, it's 26. Now, out of this, these two happen to be the one with a perimeter of 14 and an area of 12. So, if the length is 3 and the width is 4, the area is 12, 3 into 4, and the perimeter is 14, which meets our needs. Now there is another one right next to it. It says with the length is 4 and the width is 3, then the area is still going to be 12, it's 4 into 3, and the perimeter would still going to be 14. And in this particular case, out of the two that we have, which is 3 and 4, this happens to be the one with a higher value. So our answer would be length would be 4 and width would be equal to 3. Only in this case, we have the length which is longer than the width, which is more than the width, and the area would be 4 into 3, which is 12, and the perimeter would be 14. So the answer is length is 4, both in terms of meters, which is exactly the same that you would have found if you had done it with the quadratic equation. But this explanation helps students in the elementary school and probably in the middle school to solve the problem without directly trying to solve it with a quadratic equation. Thank you.